All right, welcome to today's lesson. We're going to look at another way of solving simultaneous equations by doing something called substitution. Now, normally we'd have two equations and we try and line them up and eliminate one of the variables, but this time we're not going to do that. And if you remember what substitution means, it means substituting one thing in place of another. Now, looking at the two equations, you might notice the first one has both x and y on the same side, but the second one, and I'll number them, the second one is actually in the form y equals. And this makes it really easy to substitute. So what we're going to substitute is this, whatever y equaled, in place of y in the first equation. Now, if you remember back to the elimination method, the goal was to eliminate one variable altogether so that we only had another variable that we could solve for. You might notice straight away that doing this substitution here will get rid of y in the first equation, and I'll show you what it looks like. So this is going to be our equation. I'll put brackets around it because it can get messy later on if you have negatives involved. This one doesn't, but it's helpful to put the brackets in anyway. So you might notice now that instead of having a y here, I've got an x. And this means that the entire equation has only got x's in it, which will mean that I'm going to be able to solve whatever x equals. So this is the goal of the substitution method as well, to find an equation that only has one variable in it. You might have to create it, but that's your goal. Now, I'm going to combine like terms, so this one here, with the x, and I'm going to move the 2 across to the other side as a negative 2. So my next line down will be 3x equals minus 9. Now you can clearly see here that if I divide by 3, minus 9 divided by 3 is going to be a nice whole number. So x equals minus 3. Now, knowing or remembering that solving a system of equations the goal is to find an intersection point, we need to do something with this x value. We're not finished yet. This x value has to be substituted back into either equation 1 or equation 2 to find out what y equals. Now, quick examination will reveal that this second equation here, which is already in the form y equals, would be the easiest one to substitute it back into. So I'll just say y equals minus 3 plus 2. Simplify the right-hand side, and you can see that y equals minus 1, which was pretty straightforward. Now, your final step is to write this as a coordinate point. Minus 3, minus 1. Sometimes the answer will be happy with it written like this, but I think it's best practice to get into the habit of writing it as an intersection point, because that's what we're doing when we solve a system of equations. I hope that makes sense. There's another example following. All right, this example is slightly more complex because it involves a coefficient of one of the variables. So again, we've got two equations. I'll number them. This is equation number 1, this is equation number 2, and you can see here that the second equation is again written in the form y equals. Now it won't always be, one of them won't always be in y equals, some of them might be in x equals, or some of them you might even have to rearrange completely to get a form that you can substitute in. But we'll do an example like that later on. So first of all, we're going to substitute equation number 2 into equation number 1. In place of the y. So it's going to become 2x minus 3, open bracket, whatever the y equaled, which is x plus 3, close bracket, equals minus 8. Now, this is different from the previous example in that this minus 3 here has to be expanded into both x and 3. So this minus 3 has to multiply there and there. So when I expand out this bracket, it's going to be 2x minus 3x minus 9 equals minus 8. All right. Now, what we can do now is to combine like terms. So we notice that 2x and minus 3x combine to make minus x. Minus 9 equals minus 8. I'll move the minus 9 across as a positive 9. And I have minus x equals 1. Now, negative x, I can't deal with negative x. It has to be positive x. So I need to divide by minus 1. That's the fastest way to get rid of the negative. divide by minus 1, and I can see that x equals negative 1. 1 divided by negative 1 is negative 1. So this fraction here became that whole number. Now, second last step is to substitute this x value into one of the equations to find out the y value. Don't forget we're trying to find a coordinate point. And again, equation number 2, which is already in the form y equals, is probably the best one to do because it's rather straightforward. You could sub into equation number 1, but you'd have to do some rearranging along the way. So y equals minus 1 plus 3, y equals 2. And the last and final step is to write it as a coordinate point using the information you were given. So bracket minus 1, 2. Change color in case you couldn't see the green. Remember, this coordinate point is the most important thing at the end because you are trying to find an intersection between the initial two graphs. So to recap, substitution is about substituting part of an equation into another equation to make a third equation that only has one variable. In this case it was x, other cases it might be y. It doesn't matter which one you choose. We'll do another example later on which will involve some rearranging from the beginning, but that's the purpose, to make sure that you only have one variable so you can solve an equation to find one of them, substitute it back into the second to find the other variable, resulting in a point. Now another example you might come across, or another situation you might come across, is where both equations are already in the form of y equals. So what do you do here? Well, it's actually rather straightforward. If both of them equal y, that must mean that these two sides, the left-hand sides, are already the same, which must mean that the two right-hand sides are also the same. So you can quite simply just write this equals 7x minus 8. So this effectively is the same as writing y equals y, because the initial information told us that that was equal to y and that was equal to y. So it's actually a little bit more straightforward than the previous example. So 7x minus 8. Now I'm just going to rearrange. I'll move the 2 across to that side as a minus 2, and I'll move the 7x across to that side as a minus 7x. So it's going to become minus 10x equals minus 10, which is rather nice numbers. Divide by minus 10 on both sides. Divide by minus 10, x equals 1. And what's the last step, or the second last step we have to do? That's right, substitute it back into one of the equations. And in this case, it doesn't make any difference. Neither of them is any easier than the other because they're both in the form y equals. Just remember to put your brackets in to show that you're multiplying. Y equals minus 3 plus 2. Y equals minus 1. Now for those who are wondering what would happen if I substituted it into the other equation, I'll show you. So y equals 7 minus 8. Y equals 7 minus 8, which is equal to minus 1. It didn't make any difference at all. So the final step is to make sure that we write it as a coordinate point, and there we're done. Alright, so if you come across a situation like this where they're both y equals, you are allowed to just sub the two right-hand sides or the two other sides equal to each other. And this is a method that we'll use all the way into year 12 for those who are going into higher levels of maths.